All right, Candace, do you mind turning off the front lights? Thank you. Looking at his chocolate bar from a top view, Brian states that it looks like a rectangle. State two properties of Brian's chocolate that make it a rectangle. You can say 4 right angles. You can say that diagonals are equal or measure the same. You can say that it has 2 pairs of equal sides or congruent sides. You can say it has 2 pairs of parallel sides. You could say, so these are all possibilities, okay? You could say that diagonals bisect each other. Anybody have something on there that I didn't mention that you're wondering about?
All angles are 90 degrees.
Yeah, all right angles. Yeah, all angles are 90. That's also acceptable. Use your own words. If you're stuck, you just use your own words. So 1 mark for each correct entry there. Name the following triangles. So in this case, I don't like this. We're talking about like angles. These two are the same. This one is different, right? So we would definitely say this is an isosceles because it's got 2 sides, and I don't like the markings. That's all I'm saying. Like these lines should not have been there for angles. Like this is enough. Like for angles, if you just do that and this, you're saying they're the same. This one should have 2 like that to make that one different. But this one is an acute isosceles. That's all you have. There are no numbers, so that's just what we do here. We'll give you 1 mark for that. This one is an obtuse, based just by the look of it, right? One angle bigger than 90 here, so obtuse scalene. You get another mark for that. Sketch a rhombus and label all congruent parts. A rhombus is a slanted square. I don't know if you want to put that down for yourselves on your study sheet. A rhombus is a slanted square because you know that all 4 sides are the same. You know that this angle and that angle are going to be congruent, and so opposite angles are congruent in a sense. Okay? You could continue saying diagonals. Oh, wait. The wording. I'm glad I read it again. What does it say for us to do all congruent parts? All the things that are equal to each other. All right, so technically only, not just any properties, but anything that's equal. So the 4 sides and the angles, that's it. That's it. The diagonals are not congruent. One is longer than the other. And so that's all you've got there. But remember, more properties, other properties, if you're looking through this AC to study, right? Diagonals meet at 90 degrees. That's very, very particular to a rhombus. Okay. You could say that diagonals bisect. They cut each other in half. Okay. And that I'm going to leave it at that. You could say 2 pairs of parallel sides for sure. That's good. Okay, keep going. A kite is a type of polygon. State 2 properties of this polygon. The one for me, it's easiest to remember is diagonals meet at 90 degrees. That's something, for some reason, to me, that's very unique. Okay, so they meet at 90 there. You could also say that there's 1 pair of equal angles, and they're across the short diagonal. That is probably worth mentioning. It's always across the shorter diagonal that those two are going to be found. You can say that there's two pairs of congruent sides, meaning this side is the same as that one, and this one measures the same as that one. Think that. Oh, and the short diagonal bisect. Only the short one bisects. Okay, guys, you remember that? Of course, you live and breathe quadrilaterals. Every weekend, you're just out there, right? Short diagonals bisect. Okay, the short one. So by that I mean I'm going to make another diagram because it's getting too messy. This one, the short one there, gets cut in half, not the long one. Okay. So any two gives you the mark. So we've got 2, 4, 6, 8 on this page. You're the teacher today, but don't be too generous if you're not sure, right? I'm not going to argue with you. This is mainly for you to learn. From an old exam, this one right here. Copy paste, basically. Martha is building a triangular ramp over a drainage pipe. Consider the following designs. What kind of a triangle is this? It's a right scalene, most likely. They don't tell us anything about the other sides. This one has the 80 at the top, and this one has a 120 at the top. So this one is obtuse. This one is acute. Okay, just like that, just by observation. Choose the letter that best completes a statement. The type of triangular ramp that allows a wheelbarrow to be pushed smoothly over the pipe with the least amount of effort from either side would be this one right here. I hope that's right. The bigger this angle, the bigger the angle, the lower to the ground it will be. So this one is the one you should have picked. C. Justify why this type of triangle should be used for the ramp, making reference to the base angles. This is what they wanted to get the full marks. I will just say this. A greater top angle. Okay. What happens to the base angles if the top one gets bigger? They get smaller, right? There's not much. There's only 180 to go around. So the more this one eats up, the less there is for these two to come by, right? So the greater the top angle, a greater top angle results in smaller base angles. This makes it easier to go over. Ideally, an angle of 0 would be best, but you can't have that, right? A 0 angle, now you no longer have a triangle. So the smaller it is, the easier it is to walk over. Okay? Consider the following right trapezoid. So you should know something about it. Right trapezoid, that means that you're guaranteed that those are 90s. Okay? Calculate the value of the indicated angles or sides. Let's do this one. What did I tell you about these two angles in when you have a quadrilateral? These add up to 180 every time. Same with these ones, by the way. They add up to 180 as well, 90 and 90. So you can just, to find angle X, you just go 180 minus 37, and that's 143 degrees. 1 mark for that. For Y, you gotta kind of use this triangle here, this one. So if I cut that out, 2.5 is that this one comes with me. This 90 comes with me. 6 minus 4 is 2, right? That means that this little piece is 2 and this is 4. 4 and 2 make up 6. So the 2 goes down there. This is y. Okay. If I see you do that where you cut it out and you have the 2 somewhere, I give you 1 mark already. To find y, being a right triangle, it's 2.5. It's a hypotenuse squared minus the leg squared. That is 5 point. Well, anyway, so if you do this, you get 2.25 as a remainder. You take the root of that, you get 1.92. No. 1.5. Sorry. If you use sine law or cosine law, it's actually 1.92 meters. And that's my fault. I wasn't careful enough when I came up with the numbers to actually make sure it jives. Okay, that's my fault. So if you did sine law and you got this, I still give you full marks. Okay, I'm not going to take marks off. So y, if you got that, you get 2 marks for it because there's a significant amount of work that accompanied that question. So you get 1 mark, so 3 marks for question 6, and then 2 marks for question 5. So that makes the backside worth 5 marks. 5 marks. And then I'll just let you know of something before we get to the exam. So this is total of 13. Okay, you ready? The chances that you're going to have to use Pythagorean theorem on the exam are slim to none. Like, they're going to focus on sine law, cosine law. That's what we taught you, that's what we focus on. So I'm always a little hesitant towards the end to do Pythagorean theorem because students are like, oh, wait a minute, I've got 2 sides, I'm going to find the third side using Pythagorean theorem, and they miss the fact that the triangle isn't a right triangle, okay, on the exam. So I would just say, forget about this. Okay, forget about Pythagorean theorem. It's not going to happen. Okay, it's just not going to happen. So please don't use Pythagorean theorem to solve a triangle on the exam. It's going to be sine law, cosine law. Those are the outcomes. I'm not saying, I actually think in the trades, if you go to trades like any like plumbing or woods, like if you do framing, you're going to use this a lot, but not on the exam. So that's my disclaimer here for you.